In the vast darkness of space, where stars flicker like beacons of hope, there lies a world that beckons us to dream beyond our terrestrial bounds. Welcome to a realm where icy exteriors hide fathomless depths, a celestial body known as Europa. For centuries, the idea of life beyond Earth has ignited our imaginations, and today, I invite you to join me aboard the celestial Voyager as we embark on an extraordinary journey, exploring Europa and the secrets that may lie beneath its frozen surface. Over the decades, humanity's quest for answers has taken us ever farther. In March 1979, when the Voyager 1 and Voyager 2 spacecraft glided past Jupiter's domain, their fleeting gaze captured images that hinted at an enigmatic truth: a subsurface ocean concealed beneath Europa's icy crust. This was no mere trick of light, but a whisper from a hidden world, a promise of liquid water, and, perhaps, the spark of life. As our ambitions grew, so did our curiosity. The Galileo mission in the late 1990s confirmed what many had only dared to imagine. Beneath the frozen veneer of Europa lies an ocean, a vast, hidden reservoir of water that might be teeming with chemical energy and conditions ripe for life. Now, with the recent launch of NASA's Europa Clipper mission in October 2024, a new chapter unfolds. A chapter where our instruments and our ingenuity unite in the search for extraterrestrial life. On a crisp day in March 1979, as the Voyager spacecraft gracefully slingshot past Jupiter, humanity caught its first tantalizing glimpse of Europa. Against a backdrop of swirling gas giants and cosmic dust, the images returned by Voyager 1 and 2 painted an astonishing picture. A world whose surface was a tapestry of ice, crisscrossed by fractures and ridges, and beneath which lay an unfathomable mystery: a global ocean waiting silently to be discovered. These early images ignited a spark, a relentless drive to uncover Europa's hidden nature. The hints of liquid water concealed beneath an icy shell were like fragments of a riddle written in the language of the cosmos. The mysteries multiplied when, in the late 1990s, the Galileo probe ventured into Jupiter's realm. Its instruments, designed with painstaking care, confirmed what the pioneers had suspected: Europa, with its thick, fractured ice, cradles a vast ocean, warmed by the hidden fires of its interior. Europa, with its enigmatic beauty, is a world of contrasts. Its surface is a massive canvas of ice, stretching out in glistening plains and intricate networks of ridges and fractures that tell tales of a restless past. But beneath this frozen facade lies an ocean of staggering proportions, a vast body of liquid water concealed beneath an ice shell estimated to be anywhere from 6 to 18 miles thick. Here, in the twilight of a distant solar system, gravitational forces play a silent symphony. As Europa orbits the colossal planet Jupiter, it is tugged and pulled by the immense gravitational might of its giant neighbor. This constant tug-of-war, known as tidal flexing, generates an internal heat that is as subtle as it is powerful, melting the ice from below and keeping the ocean in a liquid state even in the cold vacuum of space. Imagine, if you will, a world where the gentle caress of gravity transforms ice into water, where the constant rhythm of tidal forces sets an ancient dance in motion. It is in this hidden ocean that the seeds of life might find fertile ground, a realm where energy, in the form of heat and chemical gradients, could spark the processes that have given rise to life on our own planet. The possibility of hydrothermal vents, deep, submarine chimneys where mineral-rich water gushes into the darkness, adds another layer of intrigue. On Earth, such vents are known to harbor rich ecosystems, teeming with life forms that thrive in the absence of sunlight, nourished solely by the energy of the planet's interior. Could similar systems exist on Europa? Could the very forces that shape this icy moon also be the architects of life itself? Evidence of Europa's hidden ocean and its potential for life comes not only from the dance of gravity and ice, but also from the dramatic displays of water vapor erupting into space. In 1997, the Galileo spacecraft detected fleeting yet unmistakable signs of water vapor plumes, geysers that burst forth from Europa's surface and spewed particles into the void. These water vapor plumes, like delicate yet powerful exhalations from a sleeping giant, hinted at dynamic processes occurring far beneath the surface. They were a window into the mysterious interplay between the icy crust and the hidden ocean below, a natural mechanism by which Europa might vent the secrets of its interior to the cosmos. As our understanding of Europa deepened, so too did our resolve to explore it directly. In October 2024, NASA launched the Europa Clipper, a mission that embodies the pinnacle of our exploratory ambition. With a price tag of $5.2 billion, this groundbreaking spacecraft is the largest, most advanced planetary mission ever undertaken in our quest to understand the outer reaches of our solar system. Equipped with 9 state-of-the-art scientific instruments, the Europa Clipper is designed to peel back the layers of Europa's enigmatic facade. Among its arsenal of tools are an ice-penetrating radar that will map the hidden contours of the subsurface ocean, high-resolution cameras that will capture the intricate details of Europa's fractured ice, and infrared thermal imagers that will seek out warm anomalies, potential clues to subsurface activity. Every pass, every measurement, brings us closer to answering the age-old question: are we alone? The Europa Clipper is more than a spacecraft. It is a harbinger of hope, a symbol of humanity's insatiable curiosity, and a testament to our unyielding desire to explore even the most remote corners of the cosmos. The possibility of discovering life beyond Earth is a prize that transcends scientific inquiry. It is a testament to our eternal drive to explore, to learn, and to dream. Imagine the profound impact of discovering even the simplest form of life beyond our home. A microbial spark that defies the odds, thriving in an environment once deemed inhospitable. Such a revelation would reshape our philosophy, redefine our place in the cosmos, and ignite a renaissance of scientific discovery. Europa and Titan are more than just distant, icy, or amber worlds. They represent the vanguard of humanity's interstellar quest for life. As we stand on the threshold of a new era of exploration, we are reminded that our search for life extends far beyond the confines of Earth. It is a quest that challenges our ingenuity, tests our resolve, and ultimately expands our understanding of what it means to be alive. From the depths of Europa's hidden seas to the mysterious horizons of Titan, our quest for extraterrestrial life is a testament to the indomitable human spirit, a spirit that dares to dream, to explore, and to seek the truth that lies beyond the confines of our blue planet. Thank you for joining me on this odyssey, a voyage of exploration, discovery, and unyielding wonder. Until our next journey among the stars, keep your eyes on the horizon, your heart filled with curiosity, and your spirit ever ready to embrace the unknown. Beyond the mysteries of Europa's icy shell, the broader Jovian system remains a testament to the vast complexity of our solar neighborhood. Jupiter's swirling clouds of ammonia and water vapor dominate the cosmic stage, a gargantuan gas giant whose gravitational influence guides the orbits of numerous moons, each with its own story to tell. Among these, Io blazes with volcanic fury, its surface constantly reshaped by eruptions of molten rock. Ganymede, the largest moon in the solar system, boasts a magnetic field and a landscape of ancient craters and bright, icy terrain. And then there is Europa itself, caught in a cosmic dance, bound by the colossal presence of Jupiter, yet fiercely independent in its potential to harbor life. Scientists have long speculated that if hydrothermal vents exist beneath Europa's frozen crust, they could fuel entire ecosystems. On Earth, similar vents teem with life forms that rely not on sunlight, but on chemical energy for survival. The thought that such a thriving habitat might exist in the cold reaches of the outer solar system is both enthralling and humbling, compelling us to question the very definition of habitable. Life, as it so often does, may find a way, even in the darkest corners of the cosmos. The Europa Clipper mission, ambitious as it is, only marks a beginning. Beyond its dozens of planned flybys, scientists dream of landing a probe on Europa's surface. Such a venture would be fraught with challenges. The intense radiation emanating from Jupiter's magnetosphere could damage electronics, while the strength of Europa's surface ice, riddled with cracks and ridges, would demand careful navigation. Nevertheless, the allure of a lander, perhaps even a robotic submarine capable of melting through miles of ice. The presence of complex organic molecules, discovered by the Cassini mission, hints that Titan could be a laboratory for exotic chemistry, a place where life might follow pathways unrecognizable to our terrestrial eyes. Venturing farther still, Uranus and Neptune entice us with their own cadre of mysterious satellites, some of which could also conceal subsurface oceans. Moons like Triton, orbiting Neptune in a retrograde path, tease us with geysers of nitrogen and the potential for internal heat sources. Even dwarfs like Pluto and Ceres, once thought to be mere ice or rock, have shown signs of geologic activity and possible subsurface water. It seems that everywhere we look in the outer solar system, we find hints that the conditions for life, liquid water, essential chemicals, and energy sources, may not be as rare as once assumed. Such discoveries carry profound implications. If life exists elsewhere in our own solar system, whether on Europa, Titan, or some yet unexplored moon, it would suggest that life may be commonplace throughout the galaxy, emerging whenever conditions allow. This realization would shift our perspective of the cosmos, transforming it from a lonely expanse into a vibrant tapestry populated by countless forms of existence. Our philosophical and spiritual foundations would likewise evolve, as we confront the notion that Earth's biosphere is but one branch in the grand tree of cosmic life. Yet the journey is daunting. Space exploration demands monumental resources, unwavering patience, and the resolve to endure countless setbacks. Missions like the Europa Clipper and Dragonfly, destined for Titan, require cutting-edge engineering just to survive the harsh conditions of deep space. The radiation belts around Jupiter, for instance, can fry unprotected electronics in a matter of days, forcing mission planners to encase critical components in armor-like shielding. Even then, time is limited. The spacecraft must gather its data swiftly, each flyby a carefully orchestrated ballet of gravitational maneuvers and scientific observations. We should not underestimate the complexity of drilling through Europa's ice, either. Though various proposals exist, from nuclear-powered melting probes to advanced robotic cryobots, no single design has yet been deemed mission-ready. The ice itself may be riddled with pockets of liquid, salty brines that complicate any attempt to predict exactly how thick each layer might be. And once a probe reaches the ocean beneath, controlling it remotely from Earth, nearly 500 million miles away, becomes an intricate challenge, requiring robust autonomy and fail-safe mechanisms. For all these difficulties, the potential rewards are spectacular. Discovering life on another world, be it microbes clinging to hydrothermal vents in Europa's ocean or some methane-based organism in Titan's lakes, would stand as one of humanity's most transformational achievements. Such a finding would confirm that biology is not an isolated phenomenon unique to Earth, but rather a ubiquitous process that springs forth wherever conditions permit. This revelation would ripple through every facet of human thought, inspiring new fields of study, reshaping cultural narratives, and deepening our appreciation for the fragile ecosystems of our home planet. Nor does our fascination with life beyond Earth end with microbes. Some researchers speculate that complex organisms might evolve in these hidden seas, perhaps forming small ecosystems around hydrothermal vents. While such speculation reaches beyond current evidence, it sparks a sense of wonder that drives future missions. In time, we might witness the development of specialized submersibles designed to traverse these alien oceans, scanning for any signs of organized structures, chemical imbalances indicative of biological processes, or even the faint glimmer of bioluminescent life. In parallel, astronomers continue to scan the skies for exoplanets circling distant stars, refining techniques to sniff out atmospheric biosignatures. As this search progresses, the concept of habitability takes on a broader meaning, extending beyond our solar system and into the boundless reaches of the Milky Way. Thousands of confirmed exoplanets now fill catalogs, each one a potential stage for cosmic dramas of evolution and adaptation. The discovery of life, whether microbial or more advanced, on Europa or Titan would galvanize these efforts. It would prove that life can arise multiple times, under conditions very different from those on Earth, underscoring the likelihood that the galaxy teems with living worlds. Yet, with great opportunity comes the responsibility to protect both alien environments and our own. Planetary protection protocols aim to prevent contamination, whether introducing Earth bacteria into Europa's pristine ocean or bringing unknown organisms back from a sample return mission. These measures, while sometimes seen as bureaucratic obstacles, are crucial in safeguarding the integrity of scientific endeavors and preserving the natural state of celestial bodies. If life does exist on Europa, Titan, or any other solar system locale, it is essential to ensure that our exploration does not disrupt these native biospheres before we even have a chance to understand them. All the while, our technological innovations feed back into Earthbound applications. The engineering prowess required to develop rad-hard electronics and efficient propulsion systems spurs advances in communication technology, robotics, and materials science. Data from missions like Europa Clipper feeds machine learning algorithms that can identify surface features more efficiently, which in turn benefits industries ranging from healthcare imaging to autonomous vehicles. This synergy between space exploration and practical terrestrial applications is a testament to the long-reaching consequences of scientific inquiry, a cascade of progress that touches countless aspects of modern life. As we look forward to the next decade, space agencies around the world prepare to expand the frontiers of human knowledge further still. Plans are underway to send orbiters, landers, and possibly even crewed missions to destinations once considered unreachable. The prospect of humankind stepping onto Mars, establishing a sustained presence on the Moon, or deploying advanced telescopes into the outer solar system reflects our unrelenting spirit. In this grand tapestry of exploration, Europa remains a shining beacon, its icy crust hiding an ocean that compels us to keep asking questions. Ultimately, our search for life on Europa is about more than a single moon or even a single planet. It is about reconnecting with the fundamental questions that have inspired generations. Where do we come from? And are we alone? In the cold vacuum between worlds, as we design spacecraft and decode faint signals, we are reminded that science is not just a pursuit of data, but a celebration of curiosity, unity, and the boundless potential of the human mind. And so, our voyage continues, guided by telescopes, rovers, orbiters, and the resolute conviction that there is always more to discover. With each new mission, we draw closer to unveiling the secrets that lie beneath Europa's ice and deep within Titan's methane seas. We refine our understanding of the cosmos, one pixel of data at a time, forging a path toward revelations that may one day eclipse everything we thought we knew about life itself. Yet even as we inch closer, we remain captivated by the sheer scope of our endeavor. The universe is vast beyond reckoning, and our attempts to explore it often feel like humble steps across a boundless desert. But in those steps, we carry a spark of hope, a belief that by pressing onward, we may gain insights into the nature of consciousness, the fragility of ecosystems, and the interconnected fate of all life in the cosmic arena. Though our machines may roam where human eyes cannot, they are our emissaries of wonder, weaving stories of ice and rock, steam and starlight, truth and revelation. In time, we may look back at these early missions with a mixture of nostalgia and awe, marveling at how they opened the gates to an era of interplanetary understanding. Europa's bright scars, Titan's orange haze, and the hidden oceans of distant moons may become as familiar to future generations as Earth's own polar regions are to us. Children may grow up dreaming of forging entire settlements in these far-off habitats, pushing the boundaries of biology, engineering, and imagination, all in pursuit of cosmic kinship. This is the grand romance of exploration, the unyielding conviction that the human story is inextricably bound to the universe itself. Across centuries of gazing at the night sky, we have pieced together a portrait of reality that grows richer with each discovery. Now, with our ships sailing through interplanetary space, we stand on a precipice, one that urges us to take the next leap into the oceanic depths of Europa, the clouded horizons of Titan, and eventually beyond the confines of our solar system. Each leap invites us to redefine what is possible, beckoning us to listen to the silent arias of celestial bodies and learn their ancient wisdom. Thus, we extend our gaze ever outward, forging alliances across nations and generations to bring the. For now, as you read these words, the Europa Clipper sails through the vacuum, inching closer to its rendezvous with the unknown. Teams of researchers pore over data, perfecting flight paths, calibrating instruments, and standing ready to interpret every megabyte of information the spacecraft relays. Each question answered spawns new ones. Each mystery unlocked reveals deeper layers of complexity, and so the cycle of discovery advances. This is the heart of scientific progress, an ever-evolving story where the narrative arc bends toward knowledge, guided by curiosity's gentle pull. Thank you for journeying with me through these wonders. May your own dreams reach as far as your imagination can carry them, and may the silent realms of space whisper back their long-held secrets. Even as we bring this extended reverie to a close, the universe remains alive with questions, an eternal invitation to all those who dare to listen and learn. Let us continue to watch, to probe, and to wonder, forging a future in which humanity stands not as a lone voice in the cosmic expanse, but as one of many, harmonizing with the grand orchestra of life that may already resonate throughout the stars. In contemplating humanity's next steps, we also reflect on the legacy of those who paved our way. From Galileo Galilei's first observations of Jupiter's moons to the modern-day scientists and engineers who labor tirelessly behind mission consoles, the lineage of exploration spans centuries and speaks to an unbroken chain of curiosity. We carry forward that torch, kindled by the knowledge that every great discovery begins with a question, a hypothesis, and the willingness to risk failure in pursuit of enlightenment. Consider the intricacies of interplanetary travel, launching a spacecraft, calculating gravitational assists, and threading it through the cosmic shooting gallery of asteroids, radiation belts, and gravitational wells, all to arrive precisely at a body like Europa. Each phase requires an orchestration of talents, from trajectory planners and propulsion experts to data analysts and mission architects. With each success, new horizons open, revealing vistas that test the limits of our imagination. Our growing understanding of extremophiles on Earth, creatures living in deep-sea vents, acidic hot springs, and polar deserts, continues to rewrite our assumptions about what life needs to survive. These organisms defy odds and conditions that mimic some of the harshest environments found elsewhere in the solar system. They suggest a resilience in the very fabric of life, an adaptability that urges us to broaden our search parameters when considering where else in the universe biology might bloom. Yet even as our scientific picture sharpens, we retain a profound sense of humility. The cosmos is a tapestry of extremes, blazing supernovae, crushing black holes, swirling galaxies, and the silent vacuum in between. Our corner of it, the solar system, is but a single note in an eternal symphony whose scale defies comprehension. And yet, in that note, we find boundless variety: gas giants, rocky planets, icy moons, swirling rings, and comets that carry ancient records of our primordial past. By studying Europa's ocean, we trace pathways that could reveal how life on Earth once arose. If life on Europa follows similar chemistry, or if it has taken an alternate biochemical route, either outcome would illuminate life's capacity to adapt. One might find peculiar amino acids, or metabolic processes that use sulfur instead of oxygen, or something altogether unimagined. Even a discovery that life does not exist on Europa would hold importance. It would refine our models, helping us to discern which cosmic recipes can indeed spawn life. Thus, every piece of data, whether confirming or contradicting our expectations, draws us closer to overarching truths about life's cosmic role. Imagine the day we detect indisputable biosignatures, specific ratios of gases or chemical byproducts that can only be generated by living organisms, wafting from Europa's plumes. The immediate aftermath would be a flurry of global announcements, urgent debates, and an exhilarating cascade of follow-up studies. Philosophers, theologians, artists, and laypeople alike would grapple with the implications, pondering what it means for our species to share the universe. Would we find comfort or disquiet in realizing that life arises wherever the seeds of chemistry and environment converge? This deep contemplation inevitably extends to questions of cosmic ethics. If Europa is inhabited, how do we responsibly explore it? The drive to scoop samples, analyze them, and replicate them in labs must be tempered by the imperative to protect a potentially pristine biosphere. As we venture deeper into space, these moral quandaries sharpen, reminding us that exploration does not occur in a vacuum devoid of accountability. Indeed, the measure of our advancement might hinge not only on what we discover, but on the care we take to preserve the delicate tapestries we encounter. Despite the profound unknowns, we press on, fortified by the synergy of technology and human resolve. In the years to come, there may be moments of frustration, instruments failing, budgets tightening, missions delayed. But these hurdles pale against the overarching narrative of human enterprise that continues to push outward. Each triumph, whether it's a successful orbital insertion around Jupiter or the first whisper of organic molecules detected in Europa's frozen crust, reverberates as a testament to cooperation, intelligence, and bold ambition. We must also remember that exploration belongs to everyone, not merely those with the means to launch rockets. Education and public engagement play a crucial role in sharing these discoveries, inspiring the next generation of scientists, engineers, and visionaries. Children reading about Europa, Titan, or Mars might one day steer the very missions we now dream about, bridging the gap between imagination and achievement. Every curious mind engaged, every young dreamer encouraged, is a step closer to ensuring that our exploration remains as boundless as the universe we seek to understand. Through it all, we stand in awe of the shimmering band of the Milky Way overhead. Somewhere in that stellar expanse, billions of sun-like stars host planets, some of which may be warm and inviting, others cold and dark. Yet, as Europa teaches us, even the cold and dark places can harbor secrets of warmth and possibility. Our telescopes peer across unimaginable gulfs to read the signatures of exoplanet atmospheres, while our robots dive into alien seas right in our celestial backyard. The scale may differ, but the question remains, how often does life manage to take hold? The cosmic stage is immense, but so is our determination to explore it. Europa represents a crucial stepping stone in a broader saga, one in which humans strive to become not just observers, but participants in the grand dance of cosmic evolution. If and when we find conclusive evidence of life beyond Earth, history will pivot on that discovery. Future civilizations might mark it as the moment we truly recognized ourselves as part of a universal continuum, a single thread in the tapestry of existence that stretches across the galaxy. For now, we remain the watchers, sending our mechanical proxies into the void, awaiting their transmissions with bated breath. Each bit of data is precious, each insight hard-won. And in those ones and zeros, across billions of miles, we find the spark that has always driven us to look skyward, the spark that urges us to connect, to comprehend, and to celebrate the miracle of being. So let us continue to support these missions with fervor, to push the boundaries of knowledge, and to share the thrill of discovery with all who care to listen. In doing so, we sustain the spirit of unity that exploration fosters, a spirit that reminds us we are one species on one planet, bound by the same curiosity that has guided every step from cave paintings to cosmic voyages. May our efforts on Europa and beyond be but the prologue to an era of unparalleled insight, one in which humanity finds not only scientific revelations, but also a renewed sense of fellowship, a place in the cosmic story that belongs to everyone. Let us hold on to hope, kindle our curiosity, and keep our eyes on the stars, for we stand on the cusp of wonders beyond imagination. In the final reckoning, the pursuit of life on Europa is about bridging the gulf between wonder and understanding. It is the moment we collectively decide to answer the call of the cosmos, standing resolute in our shared curiosity. The icy crust of Europa might one day give way to our ingenuity, allowing us to peer into an ocean that has been concealed for millennia. We do not know what we will find there, perhaps only barren waters, or perhaps evidence that life, in its infinite permutations, flourishes wherever it is given half a chance. Until that day arrives, every question we pose, every mission we launch, and every tentative conclusion we draw becomes a stitch in the grand tapestry of exploration. Decades from now, new missions may land on Europa's surface, charting its terrain with robotic scouts, and either outcome will echo through the halls of science and the hearts of humanity, fueling debates, inspiring art, and driving further quests to the remote corners of our solar system and beyond. And so we stand at this threshold, yearning for answers, guided by the luminous arc of discovery that has spanned human history. We know not what we shall find, but we do know that the quest itself defines us, uniting our species in a common narrative of cosmic curiosity. Thank you for journeying through these reflections on Europa, Titan, and the enduring promise of life beyond Earth. May the wonders we encounter spur in us a deeper appreciation of our own world, a heightened responsibility to protect life wherever it arises, and an unwavering dedication to reach for the stars. In the end, this shared odyssey is far more than a scientific endeavor. It is a testament to our collective capacity to dream, to search, and to discover our place in the boundless expanse of the universe.